How does a car wash scrub dirty vehicles clean without leaving a scratch? What makes a jukebox able to play thousands of songs without getting jammed? How does a chainsaw slice through hardwood like a hot knife through butter? To answer these mysteries, we dive deep inside these and other extraordinary machines to reveal the secrets of how things work. The chainsaw. How does this machine cut through hardwoods like oak at 3 centimeters a second without doing the same to the operator? Hundreds of moving parts work together. A lightweight piston drives a toughened crankshaft. This powers a 3-road chain that runs at a colossal 110 kilometers an hour. On the outside rows, 33 razor-sharp cutting teeth can rip through hardwood, ice, and even stone. The key to the chainsaw's power isn't the teeth, it's the flat piece of metal that the chain runs around. It's called a guide bar. It has to be strong enough to support a fast-moving chain, but light enough to hold at arm's length all day long. To save weight, workers at this Virginia Beach factory build this guide bar in a very special way. It's hollow.
What we're doing here is we're taking the parts that we stamped out, outer plates and inner plates, and putting them together to basically make the guide bar.
Brian heads a team of engineers that run the massive robotic guide bar production line. It's one small part of a 45-acre factory that produces 4 million units a year.
It's such complicated equipment. I've been making guide bars for 42 years. This is the most automated system. As long as they keep it running, I'm a happy camper.
This robot takes 2 solid pieces of metal and stacks them with a hollow section in the middle. It then delivers the bar to a giant welder. 18,000 volts of electricity fuse the metal together. The hollow core makes this metal sandwich much lighter than a solid bar, but just as strong.
It's very rigid. Once it's welded, you end up with a very strong end result.
At the tip of the guide bar, a cog that spins on bearings helps the chain run smoothly. All it needs now is a chain. The design of the chain is the secret to this machine's formidable cutting speed. Three separate rows of toughened links make up the chain. At the base of the central row, long, blunt hooks slot into the guide bar for maximum stability. A toughened sprocket delivers power to the chain from the engine. Running along the outside rows, chrome-plated hardened steel cutting teeth deliver 500 cuts a second. A chain this powerful needs one tough engine. The secret to the engine's resilience lies in the way it's put together. Giant robotic lathes cut the engine's components out of solid metal. But normal steel isn't strong enough for the hardest working part of the engine, the crankshaft. This converts the up and down movement of the piston into the spinning motion of the drive shaft. Every time the piston fires, it puts the crankshaft under huge stress.
The crankshaft moves inside the chainsaw in this type of matter. This is one of the most important parts inside the chainsaw.
Keith heats the crankshafts inside a giant furnace. Do it right, and they come out harder and stronger. Get it wrong, and the whole batch is ruined.
We don't want it too hard where it's brittle, so it's a very detailed science to get the part just right. There's a lot of crankshafts going inside this furnace. It's very critical to not make any mistakes inside the process. When you scrap one, you're going to scrap 2,500 pieces. Our furnaces go up to 1,800 degrees, so it's very hot inside here.
Keith uses a specially designed loader that shields him from the furnace's ferocious heat.
We're opening up the furnace door now to put the load inside the furnace. Very, very hot back here. The summers are very brutal. You go outside, sometimes it'll be 95 degrees out there, and our guys will go out to actually cool off on the picnic tables.
The ovens bake the crankshafts for up to 6 hours. They are now 3 times harder than normal steel.
We are making the part much stronger by hardening it, and we count on it lasting for a very long time.
Workers then assemble the 297 separate components that make up the engine. The end result is a rugged single-cylinder workhorse with a better power-to-weight ratio than a supercar. With this much power, a chainsaw can cause serious injury if it kicks back and hits the operator. But there's ingenious stopping power hidden under the hood. On top of the saw, a movable handguard connects to a spring-loaded arm. This triggers a steel band that clamps tightly around the metal drum attached to the main drive sprocket. This stops the chain in under a second. If the saw kicks back, the operator's wrist forces the handguard forward, stopping the chain dead. But use a chainsaw long term, and there's another problem for the operator. The engine creates constant vibrations.
If you're using a chainsaw all day, then you're going to feel a lot of vibration in your hand.
Mark runs the chainsaw's final assembly line. Here they fit the special anti-vibration system.
It's putting the anti-vibration springs on.
These springs connect the handle the operator holds to the body of the chainsaw. They act like suspension in a car to reduce shaking in the handles.
The vibration system, actually, when you're cutting with a saw, helps take away the vibration in your hands as you're cutting.
This makes the chainsaw more comfortable to use, even for long periods of time. Across the world, millions of chainsaws are in operation every day. Built to withstand just about anything the outdoors throws at them, underneath the buzz and dust, they are hard-working machines that pack a serious punch. The Jukebox. This engineering marvel revolutionized bars and cafes in 50s America, bringing rock and roll to the people. Today's designs play high-quality digital music, but with that distinctive, warm jukebox sound. Hidden beneath a handcrafted wooden cabinet, over 1,000 components work together. A spring-loaded aluminium claw lifts the fragile CDs. A motorized arm delivers the discs to the player with pinpoint accuracy. Inside a custom-built wood casing, 5 paper cone speakers all tuned to a different pitch give the jukebox its classic warm rock and roll feel. But the biggest challenge, how do you give digital music an authentic retro sound? The secret lies in how workers build its iconic wooden cabinet. Only a few people can pull it off, and most work at this factory in England. Carpenters first glue several thin pieces of wood together to form that characteristic dome shape.
We make the cabinet using 5 layers and this special wood adhesive. We have to work quick on this process before the glue has time to set. As far as I know, we're the only people in the world that still make them this way.
Over 24 hours, the strips of wood set into a rock-solid curve. They make the cabinet like this to help the sound reverberate, adding warmth and depth.
It's important that we make the cabinet this way so that it retains that traditional jukebox sound quality. There's no gaps, there's no splits. It's ready to go to the next stage.
Today's jukeboxes use 21st century technology to maneuver the 1.2mm thick CDs into exactly the right place and back again. And they've got to do it thousands of times. A motor drives the gripping arm along a horizontal bar in millimeter steps to the exact location of the selected CD. An optical sensor checks the position. A second motor moves the arm up and down. At its end, a spring-loaded claw clasps the disc with precisely the right force to deliver it to the CD player. So how does such an intricate mechanism repeat the same process, disc after disc, without jamming? It's all down to the way engineers assemble the mechanism in-house.
There's a lot of parts, a lot. This is definitely the most technical part of the job.
Bradley is one of only 2 people in the world who knows exactly how to build the CD changer.
A lot can go wrong with these. There's only about 2mm between each disc. So you just need to make sure everything's spot on.
Bradley puts the machine through a grueling test to make sure it doesn't break down in the middle of the party.
Because this is such a crucial part of the jukebox, we test it for a minimum of 5 days where it's just running non-stop.
But playing the right CD isn't enough. A jukebox has to sound fantastic to really get the party started. Under its shell, 5 different-sized speakers are individually tuned to a different pitch. Inside each speaker, powerful magnets vibrate specially lacquered paper cones to create a rich, warm sound from treble to bass. This gives the jukebox its vintage 50s sound. A jukebox is the life and soul of the party. So as well as sounding great, it's got to look the part too. And that means a classic 50s finishing touch: bubble tubes. Getting a sealed glass tube to blow bubbles all day long isn't easy. Glass blowers bend the tubes to exactly the right curved shape by hand. It's a skilled job. Get the glass too hot and it will melt. too cold, and the tube will shatter. But putting in the bubbles is the really clever part.
The tubes are filled with a special liquid which boils at a low temperature and produces bubbles.
Andy is a master glassblower who specializes in making precision scientific equipment.
This is the most tricky part of the process, because if anything goes wrong at this point, the tube's useless and has to be thrown away. That looks fine, that should look good in the jukebox.
Now, when a heating element warms the base of the tube, it blows perfect bubbles. Finally, the jukebox is ready to rock and roll. Its classic looks and retro sound made it an American icon. It's still going strong in the 21st century, thanks to traditional craftsmanship and digital technology playing in perfect harmony. When you're fishing for big game, your reel is your best friend. It may look simple, but it's packed with technology that helps you cast long distances and even tires out your fish. A super light aluminium alloy frame houses 141 precision-built components. A spool loaded with over 500 meters of specially braided line can take the weight of 30 kilos. Inside, stainless steel ball bearings spin the reel over 10,000 times a minute. Precision gears crank up the speed and turning power of the reel. It's a miniature metal masterpiece, but it's also got to be tough enough to withstand the pull of big fish. The secret to the fishing reel's resilience lies in the way it's built in this Los Angeles factory. First step, construct a super strong frame.
Fishing is my hobby, and of course machining is my hobby too. Anytime we buy a new machine, I play on it.
Harry makes every major component of these reels in a single workshop filled with computerized metal cutting machines. The reel's main frame starts out as a solid block of aerospace-grade aluminium. Machines hollow out the center. Then a lathe removes metal from the side to leave a thin, solid frame. It even grinds smooth any sharp edges so it won't snag the fishing line.
That's the main body, finished.
The end result is both strong and light.
We lose a lot of material, but we get the quality.
The fishing reel's intricate components must also stand up to one of metal's worst enemies, salt water. This could corrode the frame and ruin the reel. So workers anodize almost every single part. This is no ordinary paint job. A series of hot chemical baths strip the metal clean. Workers dip the parts into a bath of hot acid and run electricity through them.
They'll be in here for 35 minutes. After 35 minutes, we'll bring it out. Protects the material from corrosion and salt water.
The process turns the outer layer of the metal into an oxide that's tougher and more resistant to corrosion than the aluminium underneath. Finally, workers dip the part into a special dye. This soaks into tiny pores in the anodized material, which means the color becomes part of the metal itself. The end result is a part that's harder and immune to rust. But for a fishing reel, being tough isn't enough. Once you've hooked a big fish, how does this machine tire it out enough to reel it in without breaking your line? The secret is to add drag. Inside the spool sits a brake that wouldn't look out of place on a Formula One car. A brake pad made from carbon fiber spins fast as the fish swims away. Next to this, a stainless steel disc. A lever on the reel pushes these parts together, which acts like a brake. At its max, this forces the fish to pull the weight of a water cooler. These intricate workings allow the fisherman to make it harder or easier for the fish to pull out the line. When the fish is worn out, he can reel it in. This is an extremely complex mechanism, so workers have to assemble each reel by hand. They must put together 141 different components in exactly the right order.
Every time I check the reels, every time I ask myself, would I buy this reel?
Eliza is the eagle-eyed quality controller. She checks every single one of the reel's functions.
I check the clicker, it's a fish line. I check the shifting button, low gear and high gear. And then the last thing, I double check if I have a free spool on both directions, upside and down. So the reel is ready to go.
The modern fishing reel doesn't guarantee you'll catch the big one, but in the epic battle between humans and fish, it does tilt the odds in our favor. The car wash is a true engineering wonder. The biggest robot that we come face to face with in our daily lives. How is it possible for a single machine to clean different-sized cars far better than the human hand? Over 1,000 components work in perfect unison. A conveyor belt that can haul over 30 tons. 4 giant brushes spin 90 times a minute. 40 rinsing jets pump out 2 liters of water every second, while 8 dryers blast air at 300 kilometers an hour. This workhorse is designed to do one thing: clean your car in 3 minutes flat. The inside of a car wash is a hot, wet, chemical tornado. It's one of the most hostile environments you can imagine for any machine. The secret to the car wash's resilience lies in the way engineers build the huge metal skeleton that holds it together. These metal arches support all the car wash's crucial machinery, from the soap sprays to the brushes and dryers. They'd quickly corrode if made of normal steel. Instead, welders make them out of aluminium girders that are completely immune to rust. While humans build the arches, robots weld the smaller components to make sure they run flawlessly.
This is the same kind of robot they used in Iron Man. It's true, though.
Kenny wrangles the robots at one of the biggest car wash factories in the US.
Robots are great. You can weld anything from drive shafts to little tiny parts. The robot is so flexible, it's amazing.
This robot welds the tough steel rollers at the base of the skeleton that form the car wash conveyor belt.
Well, these parts are important to be welded properly because they actually pull your car down the conveyor. So they're moving thousands of pounds of vehicles down, and if anything breaks, your car is stuck in the conveyor.
The conveyor has to tow 2-ton cars to exactly the right position for a perfect clean. The secret to how it works lies hidden underground. A hardened steel 80-meter-long logging chain, welded to toughened four-wheel rollers, pulls 5 cars through the machine at a time. Electrics don't mix with the wet and hostile environment of the car wash, so a hydraulic motor, powered by high-pressure oil, drags even the biggest car to exactly the right place at the right time. The rollers pull the car at precisely 17 centimeters a second. Next task, scrub the car clean. These fabric brushes must scour the car body from top to bottom without leaving a scratch. The secret to how they do that lies in how workers cut the soft fabric that make up the brushes.
And for this one brush, it's 216 pieces. So that's a lot of cloth.
Jimmy has made car wash brushes at this Florida factory for nearly 14 years.
This is how it comes out the machine. And this is cutting at a 30-degree angle. This is how it would wash your car.
When assembled, the angled pieces make the brush wider at the top and the bottom, so it matches the curve of the car's body.
We don't really have a square car. We have an oval kind of shaped car. The deeper angles washes the car right up to the window. You want to make it clean and pretty. After we're finished cutting, we take these over to her, and then she sews the attachment.
Millions of microfibers, each 100 times thinner than a human hair, make up the cloth. This makes it incredibly soft, but also water repellent, so it doesn't soak up grit or dirt that might scratch the car. It's smart fabric, but the machinery that holds it is even smarter. In a car wash, the giant cleaning brushes spin at up to 25 kilometers an hour. They must hug a car's bodywork, but not smash into it. So inside is a cunning design. The arms holding the brushes rotate on low-friction hinges. A car will easily push them apart as it moves down the conveyor. On top, a set of air-powered pistons push the brushes back against the car with precisely the right pressure to ensure a deep clean without damaging the paintwork. The 4 giant side brushes work in combination with wheel brushes, long strips of fabric that scour the roof, and high-speed water jets. The final challenge: dry the soaking wet car in 15 seconds flat.
When you're drying a car, you want to get as much air moving across that car to get that water dispersed off and moved out of the way. You know, so the more air you can produce, the better car that you'll have at the end.
Ray knows pretty much everything there is to know about drying cars.
I started with the company back in '99. I started out in these 2 departments here, the air dryers and the vacuums, and this has been my home ever since.
These machines blast air at 300 kilometers an hour.
The heart of the air dryer is actually this impeller right here. This is what's going to produce your air.
A huge 15-horsepower motor powers the impeller. It pulls air in from the side and spits it out of the nozzle at the front.
So as this impeller's turning, you're rolling the air out, just like in a hurricane. So you're taking that air, the air is being sucked through here, it's being pushed out through that nozzle.
The impeller spins 3,600 times a minute, 6 times faster than a helicopter rotor. So Ray has to make absolutely sure it won't fly off and cause an accident.
Usually go around 3 times, quick shots like that. Then after that, what I'll do is break out my trusty torque wrench, I'm at torque right now. So now I know that that's 100% good.
Across the world, an army of hundreds of thousands of car washes clean millions of cars every day. It's one of the hardest working machines around, doing dirty work so you don't have to. Without the blender, we wouldn't have crushed ice, soups, or smoothies. But blending is more difficult than you might think. It takes serious power to pulverize rock-hard frozen fruit in seconds. 148 super strong components work together. At the heart of this blender sits an 1800-watt motor more powerful than some motorbikes. Inside a toughened plastic jug, a hardened metal drive shaft spins twin steel blades at hurricane speeds to pulverize everything in their path. The jug of a blender is cleverer than you might think. Designers have spent years making innovative shapes that actually help blend food better.
It all starts here. We produce 435 jars in 8-hour shift, 1,300 jars a day.
Eduardo runs the huge plastic injection molding machine that makes the blender jars at this US factory. First, it heats plastic granules to melting point, 155 degrees Celsius. Then it injects the liquid plastic into a highly polished metal mold.
The plastic gets injected right through the center of this side, and it comes out and it just, covers this area. And during that time, the material has the opportunity to get hard in there, so when the mold opens, the part is ready, to be taken out.
The most important thing about this jug is its shape. It has 5 sides.
1, 2, 3, 4, and this is the 5th side right here.
Engineers make the jug shape irregular and put ridges inside to stop a whirlpool from forming. This forces more material down into the blades.
It helps stop that vortex, and it makes the food, anything that you're blend better.
A clever jug is a good start, but it takes a lot of power to smash through nuts and solid ice. So under the hood sits a seriously souped-up electric motor. 68 metal plates welded together wrap around 100 meters of tightly wound copper. These work together to spin the rotor inside at 18,000 times a minute, faster than a jet engine. This drives the blades at a colossal 300 kilometers an hour. It takes a very special drive shaft to channel all that raw power from the motor to the blades.
On this machine, we run the drive shaft, which connects the blade that's in the jar onto the actual motor of the machine.
Ben runs the machines that make the most important metal parts.
It takes a raw piece of bar stock, and it'll go through and turn it down to the diameter that we need.
They carve the shafts out of toughened stainless steel.
So here we have the finished product of this machine. This here is the splines, and what it does is it connects onto this inner spline here, and it creates a really tight bond, and that gives us the extra strength we need to power our blade at the RPMs that we do.
The drive shaft passes up through the base of the detachable jug to the blades inside. So how come the jug doesn't spring a leak? Hidden inside, high-speed carbon steel bearings allow the drive shaft to spin at maximum speed. Around a second bearing, special Teflon washers make a low-friction seal between the jug and the spinning drive shaft. This means the blender can safely smash through nuts, ice, and liquid without spilling a drop. The seal is a precision part, so robots assemble it on a specially designed production line. They first drill a hole in the base of the jug, then fit the bearings and seals. The blade, surprisingly, is completely blunt. With all that power from the motor, the blade doesn't need to slice through food and ice, it simply pulverizes it. On the final assembly line, workers put together the body of the blender by hand. Every fitting must withstand the intense vibrations caused by the motor.
Because of the power that goes through it, everything has to be super secure.
This highly skilled team assembles a blender body every 2 minutes.
So we put the armature in and then we check the bearings and make sure nothing's clicking.
I'm gonna grab a top housing, and this is where the electronic board is gonna sit. That's what protects it when it gets closed. There's a lot of vibration, yes, so we wanna make sure that everything stays in place. That holds all the little parts that go onto it, like the coils and stuff, it holds it down. And then it gets passed to the next station.
Finally, they give the whole thing a tough plastic housing.
That goes around these little legs. And then I'll screw the middle housing down. And that's it.
This tiny hunk of pure processing power is a miniature hot rod on your worktop. It might not look mighty, but it's one of the most powerful machines in your kitchen. The bike pump. It looks simple, but it's a masterpiece of precision engineering packed with intricate components. So how does it fill your tires with high-pressure air without blowing up in your face? Inside this pump, 74 precision-built parts work together. A flexible leather plunger traps air in the pump's body. A brass spring-loaded valve directs this air down a reinforced hose wrapped in a tough stainless steel braid. Inside the chuck that attaches to the bicycle tire, synthetic seals ensure an airtight fit. Keeping so many moving parts airtight is a serious engineering challenge. At this US factory, workers machine the small metal parts to 0.002 of a centimeter accuracy to make sure they fit together perfectly. This takes some skill, even with computerized lathes.
I've done this for 25 years.
Larry is a master machinist who can turn a lump of metal into pretty much anything.
Not very often I run into something that's hard to figure out.
He'll turn this bar of stainless steel into the key component that attaches the pump hose to the wheel. Computer-controlled cutting heads form the outer shape, then drill out the center to let the air through.
So this is the chuck body. There's parts that go inside, there's a cap that screws on, and this fits over the valve stem on your bike. Yeah, this part should outlast me.
Workers then assemble all of the 74 parts, including Larry's, by hand. They've been doing it this way since the company started back in 1917. One of the most important components isn't made of metal.
This is 3.5mm full grain hide. It's the same that's used in modern day, like luxury briefcases, suitcases.
Josh runs the company, but still makes time to assemble pumps on the shop floor.
And because the leather is so stiff, you want to take your finger and sort of begin to work it so that it's flexible. It's like breaking in a baseball glove.
The washer must be tough. Only leather will do. Rubber wouldn't last as long.
This is our main barrel, which has the inner diameter honed to a mirror finish. As we draw it back, the air can pass around it to fill the chamber, and then as it pushes forward, the air pressure causes it to flare outward against the wall of the barrel, giving you a seal.
The air then flows through a one-way valve and out into another critical part of the pump, the pressure gauge. This is one of the most intricate parts of the whole pump. As air rushes into the pressure gauge, it pushes against a rubber diaphragm. This flexes upwards and hits a spring-loaded pin attached to a needle. As the air pressure mounts, it drives the pin up and rotates the needle to measure the air pressure with supreme precision. Across Europe, we cycle over 600 million kilometers every day. Without the deceptively clever bike pump, none of these trips would be possible. The mighty car wash, the chainsaw, and the blender. What's inside isn't always big, but it is clever. The next time you see one of these machines, remember, there's more to how things work than meets the eye.